Previously, we have considered the path integral representation of a free particle state and also simple harmonic oscillator. Now let's consider the wave function. Represented by the path integral. So the wave function of the final state xb tb can be written as inner product between xb tb and some state function psi. And we also have the following completeness relationship: xt tt is equal to 1. So that means the wave function at xb tb can be written as the inner product of xb tb state with the psi, and it can be written as the following integral formula: xb tb xata xata psi and dxa. So we means we have to written as this x. This must be x. Or dx. So for this reason, many people write this as a propagator: xb tb xata propagator. And of course, this is a wave function at xata. And for free particle, we already have xb tb xata is m 2 pi I h bar tb minus ta 1/2 exponential I over h m over 2 xb minus xa square tb minus ta. So let's try to find the time derivative of this propagator. Partial tb partial xb tb xata, which is partial tb m 2 pi I h bar tb minus ta 1/2 exponential I over h m over 2 xb minus xa square tb minus ta. So we first differentiate the first part. That means we have 1/2 m 2 pi I h bar tb minus ta minus 1/2, and we have minus m 2 pi I h bar tb minus ta square exponential I over h m over 2 tb minus ta xb minus xa square plus, now we have the partial derivative of the exponential function. So that means we just leave the factor unchanged, 2 pi I h bar tb minus ta 1/2 exponential I over h m over 2 xb minus xa square tb minus ta minus I over h m over 2, and we have this xb minus xa tb minus ta square. So this can be combined them together. With a common factor. M over 2 pi I h bar tb minus ta 1/2. Then we have the following formula. Minus 1/2 m over 2 pi I h bar tb minus ta times m over 2 pi I h bar tb minus ta minus I over h m over 2 xb minus xa tb minus ta square. So this cancels this. This is square, so this cancels this and this. So we have the following formula. This must be square. So we leave the common factor out, m over 2 pi I h bar tb minus ta 1/2 minus 1 over 2 tb minus ta minus h bar over I m over 2 so xb minus xa square tb minus ta square. So IH bar partial TB partial XB TB XATA is same as m over 2 pi IH bar TB minus TA 1/2 minus IH over 2 TB minus TA plus M over 2 XB minus XA square TB minus TA square. So this is the time derivative part. Now let's calculate on the other hand partial XB partial XB TB XA TA is the factor doesn't have contained any dependence on the XA or XB, so we just leave it there. However, the exponential component contains XB minus XA square over TB minus TA. So we have to differentiate this. So that means we have H over I and M over 2, but twice over XB minus XA TB minus TA. So these two cancels each other. So this becomes M over 2 pi IH bar TB minus TA 1/2 exponential I over H M over 2 XB minus XA square TB minus TA times I over H times M XB minus XA TB minus TA. The second derivative becomes the following: XB square XA TA H TB minus TA 1/2 exponential I over H M over 2 XB minus XA square TB minus TA plus we have IM over H bar square XB minus XA TB minus TA square plus the same coefficient TB minus TA 1/2 exponential I over H M over 2 XB minus XA square TB minus TA times I over H M 1 over TB minus TA. So this can be combined as the following: M 2 pi IH bar TB minus TA 1/2 exponential IM over H bar 2 XB minus XA square TB minus TA times minus M square over H bar square XB minus XA square TB minus TA square plus I over H M over TB minus TA. So minus h bar square over 2m partial square partial xb square xb tb xa ta is m over 2 pi I h bar tb minus ta 1/2 exponential I over h m over 2 xb minus xa square tb minus ta times m over 2 xb minus xa square tb minus ta square minus two over IH bar 1 over TB minus TA, and this turns out to be the same as this IH bar partial TB XB TB XA TA. So we have the following formula: IH bar partial TB partial XB TB XA TA is minus h bar square over 2m xb tb xa ta. So as a result, partial tb psi xb tb is same as partial tb partial xa xb tb xa ta xa ta psi minus h bar square over 2m partial square partial xb square dxa xb tb xa ta xa ta psi is h bar square over 2m partial square partial xb square psi xb tb. So that is Schrödinger equation for free particle. For the harmonic oscillator, we have the xb, tb, xa, ta is m omega 2 pi I h bar sine tb minus ta exponential h bar per I m omega sine omega tb minus ta xa square xb square cosine omega tb minus ta minus 2xa ta. So I'd like to leave it as homework to show that IH bar partial t partial xb tb xa ta is minus h bar square 2m partial xb square xb tb xa ta plus harmonic oscillator is potential energy 1/2 m omega square x square xbtb xata. So this would be the homework problem. So let's stop for now.